Hi everyone. Today we are going to be talking about solving quadratic equations, and we're going to interpret the solutions with respect to the corresponding relations. We're going to be looking at maximum and minimum problems, as well as problems where we need to use the quadratic formula. Okay, go ahead, grab a piece of paper and a pencil, and let's get started. When determining the maximum or minimum, height, value, cost, revenue, etc., we need to find the vertex form of the equation by completing the square. So first, let's recap what is the vertex form of a quadratic equation. So hopefully you remember that it is y is equal to a times x minus h squared plus k, where h and k are the coordinates of the vertex. Okay, let's recap the quadratic formula next. So when determining the zeros, the roots, or the x-intercepts, we might be asked questions like when does the object strike the ground, how long is the object in the air, etc. So we will need to use the quadratic formula to help us determine the answer. So the quadratic formula, if you recall, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's look at our first word problem. So our first example, a ball is thrown up into the air. Its height h in meters after t seconds is h is equal to negative 4.9 t squared plus 38t plus 1.75. A. What is the height of the ball after 3 seconds? So this is telling us time is 3 seconds. So we are going to substitute t is equal to 3 into the equation. So we're going to write let t equal 3. And we're just going to go ahead and replace all of our t's with 3's. So h is equal to negative 4.9 times 3 squared plus 38 times 3 plus 1.75. So h is equal to negative 4.9 times 9 plus is 114 plus 1.75. Okay, go ahead and simplify. You can key this in on your calculator. 44.1 plus 114 plus 1.75. So that simplifies h is equal to 71.65. So therefore, after 3 seconds, the height of the ball is 71.65 meters. Okay, let's go ahead and look at part B. So same question except for part B, this time asks for what length of time is the ball above 50 meters? So 50 meters is referring to the height. So I'm going to replace my h with 50 and then solve. So 50 is equal to negative 4.9 t squared plus 38t plus 1.75. So I'm going to next subtract 50 from both sides. And now we can use the quadratic formula to help us find our zeros, or in other words, the t value. So this time I'm going to use t equals instead of x equals because that is the variable that my original question uses. So it's still the same formula, so t equals negative b, so negative 38, plus or minus the square root of b squared, 38 squared, minus 4ac, so minus 4 times negative 4.9 times negative 48.25, and divided by 2 times negative 4.9. So simplifying, t is equal to negative 38 plus or minus the square root 1,444 minus 945.7 divided by negative 9.8. So t is equal to negative 38 plus or minus the square root of 498.3 divided by negative 9.8. So we're going to have two zeros because the number underneath the square root is greater than 0. So t is equal to approximately 1.6 seconds. So it gives us t is equal to approximately 1.6 seconds, and t is equal to approximately 6.2 seconds. So we can say that the ball is above 50 meters between 1.6 seconds and 6.2 seconds. So in other words, the ball is in the air for 4.6 seconds. Okay, let's look at part C. When does the ball strike the ground? So we're looking for the 0. So we're going to let the height equal 0, and we're going to use the quadratic formula to help us find our root. Okay, so let's go ahead and substitute into the quadratic formula. So t or x is equal to negative b, negative 38 plus or minus the square root, 38 squared, minus 4 times AC, so negative 4.9 times 1.75, all divided by 2a, so 2 times negative 4.9. Okay, so this is very similar to our previous example. Let's go ahead and substitute it into our calculators. So if you look underneath the square root, we have a number that's greater than 0, so I know I have two real roots. So let's go ahead and calculate our t values. So t is equal to approximately negative 0.046. And this one is inadmissible because time cannot be negative. And t is equal to 7.8. So therefore, the ball will strike the ground at approximately 7.8 seconds. Okay, let's go ahead and look at our next example. Example number 2. The path of a basketball shot can be modeled by an equation h is equal to negative 0.09d squared plus 0.9d plus 2, where h is the height of the basketball in meters and d is the horizontal distance of the ball from the player in meters. Part A. What is the maximum height reached by the ball? Whenever you see the word maximum or the word minimum, we know we are looking for the vertex. So in order to find the vertex, we are going to be completing the square. So maximum is our clue that we're looking for the vertex, and the maximum height is the clue that we're looking for the y value of the vertex, or in other words, the k value. Okay, let's go ahead and subtract 2 from both sides. So we have negative 2 is equal to negative 0.09d squared plus 0.9d. Okay, so after we subtract 2 from both sides, we are going to divide each term on the right by negative 0.09. Okay, so we're going to take half of our 10d and we're going to square it. So this 25 is going to go after the 10d, and remember this helps us make our perfect square trinomial. So d plus 5 squared. Next we need to multiply 25 by the negative 0.09 by the a value, and we're going to add that to the left side where the negative 2 is. Okay, now that we've added the negative 2.25 to the left, we can simplify on the left and get negative 4.25 is equal to negative 0.09 times d plus 5 squared. And the last step is we need to add 4.25 to both sides. Okay, so this shows us that our vertex is negative 5, comma, 4.25. So we're looking for the y value of the vertex, and so the y value of the vertex is the 4.25. So the maximum height reached by the ball would be 4.25 meters. Okay, let's go ahead and look at example B. So for example B, how far is the ball from the player when it reaches its maximum height? So we're still using the vertex because we have maximum height, but this time we're looking for the x value of the vertex. And since we already found our vertex in the previous example, we can go ahead and use that vertex to help us solve here. So just rewriting our vertex form of the equation, h is equal to negative 0.09 times d subtract 5 squared plus 4.25. So remember the vertex is positive 5, comma, 4.25. So if we're looking for the x value of the vertex, the answer is 5. So the ball was 5 meters from the player when it reached its maximum height. Okay, let's go ahead and look at part C. How far is the ball from the player when it hits the ground? So this time we're looking for the 0. So it hits the ground, that's a 0. Or in other words, the x-intercept. So we're going to use our quadratic formula and substitute in to find our zeros. So you could use x equals, or in this case, we have d's in our equation. So I'm going to write d equals negative 0.9 plus or minus the square root of 0.9 squared minus 4ac, so minus 4 times negative 0.09 times 2, all over 2a. So all over 2 times negative 0.09. Okay, go ahead and simplify, please. Okay, finally, let's simplify underneath the square root. So negative 0.9 plus or minus the square root of 1.53 all over negative 0.18. Looking underneath the square root, I can see that we have two zeros. So our zeros are d is equal approximately negative 1.87 and d is equal approximately 11.87. So the first distance is inadmissible because distance cannot be negative. So therefore, the ball was 11.87 meters from the player when it hit the ground. Okay, let's look at our next example. Example 3. A cliff diver in Tobermory, Ontario dives from about 17 meters above the water. The diver's height above the water, h in meters after t seconds, is modeled by h is equal to negative 4.9 t squared plus 1.5 t plus 17. How long is the diver in the air? So we're looking for the zeros again here. So how long is the diver in the air? So we're going to be using our quadratic formula. So t is equal to negative 1.5 plus or minus the square root of 1.5 squared minus 4 times negative 4.9 times 17 all over 2 times negative 4.9. Okay, let's go ahead and simplify. Okay, simplifying, t is equal to negative 1.5 plus or minus the square root of 2.25 plus 333.2, all divided by negative 9.8. Okay, we are going to get a positive number underneath the square root, which means we have two zeros. Let's go ahead and find those zeros. So simplifying underneath the square root, we get 335.45. So next we're going to find our zeros. So t is equal approximately to negative 1.72, which is inadmissible because time can't go backwards. And t is equal to 2.02. So therefore the diver is in the air for approximately 2.02 seconds. Okay, next example. The height of an object thrown downward off of the peace tower is given by h is equal to negative 5t squared, subtract 5t plus 90, where h is the height above the ground in meters and t is time in seconds. What is the object's maximum height? So maximum should be your clue that you're finding the vertex. So we're going to subtract 90 from both sides. Next, we're going to divide out the a term, so negative 5. And we're going to make our little side calculation to figure out what number half of the b term is. So half of 1 squared is a quarter. So remember, inside the brackets there, now we have a perfect square trinomial. And last but not least, we need to multiply negative 5 by our 1/4. And we're going to add negative 1/4 to the left side. And simplifying on the left, we get negative 365 divided by 4. And we can write that as 91.25. So therefore the object's maximum height is 91.25 meters. Okay, let's take a look at our last example, part B of this question. How long does it take the object to hit the ground? So when you see hit the ground, you know we're looking for a 0. We're going to use our quadratic formula and substitute in to find our 0. So t is equal to negative b, so negative 5, and we have a negative, so it's just 5, plus or minus the square root of negative 5 squared, minus 4 times negative 5 times 90, all over 2 times negative 5. Okay, go ahead and simplify. Okay, looking underneath the square root, I have a positive number, so I know I'm going to have two zeros. Okay, let's keep going. Okay, so we have t is equal to approximately negative 4.8 seconds, and t is equal to approximately 3.8 seconds. And since time cannot go backwards, we can say that negative 4.8 is inadmissible. So therefore, it takes the object 3.8 seconds to hit the ground. Okay, that's it for today. Thank you very much for your attention. Bye-bye.